What's up, Kim Possible fans? Miss Sorensen here with video 22. Here we'll be tackling some harder conditional probability problems. Let's get started on this. Just as a reminder, this is our formula for conditional probability. We'll be changing it slightly. We'll be changing this to the probability of B and A divided by the probability of A. But essentially, it's the same exact formula. And just as a reminder, what does this symbol stand for? That is given. So this is the probability of B happening given that A has already happened. All right, and just check out this kind of pattern here. Notice that we've got B and A. So we're just kind of doing both, and then divided by, we've got our denominator here. Okay, and like I said, the only thing we're changing is we're going to write probability here as opposed to the number. All right. Here's our first problem. Miss Sorensen has a box of jelly beans and you're about to choose two. The box has purple jelly beans, gross, and green jelly beans, yum. 15 jelly beans are purple and 5 are green, so we have a total of 20 jelly beans. Given that the second jelly bean chosen was green, find the probability that the first was purple. You instantly know that this is going to be this type of problem. By this type, I mean this type of problem right here, because of one word in your problem. And that one word is given. So our first step here is really to try to write this correctly in the formula. So I've got the probability, and what am I being given? I'm being given that the second jelly bean chosen was green. So remember, that given is right here, so I'm being given that the second was green. So that's why it's going after the given, because it literally says given right here, and then I have second green. But what am I trying to find the probability of? I'm trying to find the probability that the first was purple. So I should write first purple in here. So that's our first step, is to write that properly. And the key is to find that word given, and whatever you're given goes second after that given symbol. The second part of this problem is writing the formula out. Kind of expanding it, if you will. So this is going to be the probability of, I'm going to combine these two things. The first was purple, and the second was green. So that is this right here. The first was purple, and the second was green. Combining the two, just putting an and to them. Divided by the probability that the second was green. So that really is equal to the formula that I have above. Now, what is the probability of having the second green? Now that gets a little tricky, right? If you have to think about what are the ways that you could have second green, well, remember, you're pulling two jelly beans, so you could have pulled a purple and then pulled a green. Isn't that second green? It sure is. But what's the other thing you could have had to have that successfully have happened? You could have had a green. So there are actually two different ways that we could pull a second green when we're pulling two green beans. We could have purple then green, and then green then green. So we're going to have to add up those two possible situations there. All right, let's go ahead and let's start plugging into this formula. Let's tackle the numerator here first. All right, what's the probability of first purple and then second green? So that's going to be equal to first purple. Well, how many purples are there? There's 15 out of 20 jelly beans. And then what's the probability of, if we picked out a first purple, of getting a second green? Well, we've got 5 green left out of 19 total jelly beans, because we've already picked out a jelly bean in this situation here. All right, so that's our numerator. Boy, I'm really slanty today, aren't I? All right. This is bugging me. Is it bugging you? Let's see if I can make that straighter. All right, now let's go ahead and tackle this situation in the denominator. Remember, we're trying to find the probability that the second jelly bean that we picked was green. So we've got two situations. We could have picked out a purple then a green, or we could have picked out green, green. So let's do the first one. Let's do this one right here, purple then green. So picking out a purple would be 15 out of 20. And then picking out a green, I'd be having 5 green left out of 19. Okay, so I have successfully done this one. But there's another way to get second green, and that would be the green-green situation right here. So our green-green would be, how many green do we have? 5 out of 20. Then if you've picked a green right here, we're now down to 4 greens out of 19. So now I've successfully represented this situation right here. All right, now, have you noticed anything about our big fraction here, that there's something in common? Did you notice that we have 20s and 19s absolutely everywhere? All right, so if you've noticed that, we can actually multiply everything by 20 times 19, 20 times 19. Here whoa, Jesus Christ!
Hey guys, Deputy Hunter. Thanks for doing math that I can't do. You're doing a great job. Keep it up.
Sorry about that. Deputy Hunter just came in and scared the living daylights out of me. Let's continue. So we can multiply by 20 times 19. So here we can have 20 times 19. The 20 cancels with that. The 19 cancels with that. Here the 20 cancels with both of these. The 19 cancels with both of these. And what are we left with? We are left with 15 times 5, right? That's 15 times 5 right here, which is going to give me 75, divided by 5, so what? 15 times 5 plus 5 times 4, right? And that's going to give me 75 over 95. Go ahead and press enter in your calculator after doing that. Press math fraction, and you're left with 15 over 19. Yeah, I realize that these problems are a little bit more challenging, but they really don't look much different than that. So I think after doing the next one, and maybe one more, we'll really start to get a handle on this. All right, so Ms. Sorensen has a deck of cards, and you're about to choose 2 cards. Given that the second card was red, find the probability that the first card was black. So we've got the probability. Again, I always recommend putting the given symbol there. And we're given that the second card was red. So we've given second was red. Find the probability that the first card is black. So first is black. So this is going to be equal to the probability of first black and then second red divided by the probability of second red. So just remember, I just combined the 2 on top, and then I did divided by the probability of the second thing there. All right, now, as a reminder, this bottom one is a little bit trickier. What's the probability of second red? Well, you've got picking a black then a red, but you've also got picking a red and a red. So we're going to have to break that down. All right, let's go back and let's calculate our numerator. So our numerator is going to be first black. Well, that's going to be 26 out of 52. And then second red, well, if we picked out a black, we're left with 26 reds out of 51. And that's it for that. Okay, now let's go ahead and tackle the denominator. Let's go black, red. So that'd be 26 over 52. And then a red would be a 26 over 51. Actually, the same thing as we have above. And then what about the red, red? Well, we've got red, red would be 26 over 52. And then we picked out a red, so now we're down to 25 reds out of 51. Now, do you notice here that we have a common fraction as well, just like on the last problem? If you did, that's great. We can multiply by what? 52 times 51 over 52 times 51, right? Which is 1, because we've got the same fraction on both. So the 52 cancels with the 52 here. The 51 cancels with that. Here the 52 cancels with both of these, and the 51 cancels with both. All right, so what does that leave us with? Let's go ahead and write this as a reduced fraction here. We're left with 26 times 26 over 26 times 26 plus 26 times 25. All right. So what does that leave us with? We're left with 676 over 1376, and that reduces to 26 over 51. Pretty close to half, but it's not quite. All right, let's do another one. And if you want, you can go ahead and pause this video, try it on your own, and then see if you get the same thing as me. It is our last problem for this topic. Ms. Sorensen's picking out 2 random volunteers from the class. Given that she picks out a girl second, what's the probability that she picks out a boy first? Use the data in the class right now. Wah wah. Let's pretend like we have 5 girls. And let's say we have 10 boys. All right. So again, we look for the word given. Given that she picks out a girl second, so probability of given girl second. What's the probability that she picks a boy out first? So first boy. So this is going to be equal to the probability of first boy and second girl divided by the probability of second girl. And then I always like to say to myself, well, what is this denominator going to be? Well, the denominator is going to be either boy-girl or girl-girl, right? Both of these situations, you've got your girl second. All right, let's tackle the numerator. So what's the probability of first boy and second girl? So we've got to tackle the first boy. So first boy is going to be, there's 10 boys out of 15 students. So I just did first boy right here. Now let's do second girl. So we're still left with 5 girls in the class because I picked a boy, but I am left with 14 students in the class. All right, now let's tackle the denominator. Probability of, let's do boy-girl first. So boy-girl is actually the same thing that we just did up in the numerator. So I'm just going to copy that down. And now I've got to tackle girl-girl. So girl-girl would be 5 out of 15. And then we've gotten rid of a girl, so it's now down to 4 girls out of 14. Okay, what can we multiply both of these by? If you said 15 times 14, you are correct. So 15, 15, 14, 14, 15, 15, 15, 14, 14, 14. We've got all that canceling. So what does that leave us with? That leaves us with a 10 times 5 divided by a 10 times 5 plus a 5 times 4. Okay, that gives us 50 over, well, that's going to be 50 plus 20 is 70, and we know that 50 70ths reduces to 5/7. And that's our answer. All right, hope you enjoyed that topic. I think it's a little bit challenging, but really they look the same after a while. Thanks so much, everyone.